Hi everyone, welcome to the final part of the Surds topic. This is part 7. In our last lesson, we looked at rationalising the denominator, and that's what we're going to look at today as well. However, the difference is, today we are going to be looking at binomial denominators. Can you remember what we looked at last time? Rationalising the denominator, that'll be better. We looked at monomial. Okay, monomial last time, this time it's binomial. And the difference is that monomial denominators only have one term, whereas binomial means two terms. And we saw binomial with surds, for the first time in part 5. So let's just recap, let's just write what binomial means. Okay, binomial means there are two terms. Okay, so what are some examples of two terms that we might see? 2 plus root 3, or 5 take away root 2, something like that. Okay, so we're going to start by looking at something like this. 5 over 5 minus root 2. Now we can see that the denominator of this fraction has a surd in it, the root 2. So if we were to get rid of that, or we wanted to get rid of that, how would we do it? Well, based on last week, okay, we might go, well, we multiplied by the surd, because a surd times itself just becomes a rational number. So let's try that. Let's times by the square root of 2, and whatever we do to the bottom, we do to the top. And let's see how we go. On the top, we have 5 root 2, and on the bottom, this root 2 has to be multiplied by both terms. Okay, so 5 root 2, and then root 2 times negative root 2, well, that's just minus 2. Okay, right, this doesn't actually look that helpful, because when we look at the denominator here, it is not rational. And after all, we're trying to rationalise the denominator, so this obviously hasn't worked for us. So what are we going to do? What are we going to do? Well, if you remember back to part 5, when we had a binomial product, there were some cases where the answers were rational. They were the cases where we had a difference of 2 squares. Remember, a plus b times a minus b is just a squared minus b squared. And in terms of surds, what we saw was that the product of two surds like this, which we called conjugate surds, okay, so the product of a binomial surd and its conjugate and its conjugate, getting ahead of myself, and its conjugate always resulted in a rational number. Okay, so the product of a binomial surd and its conjugate is always rational. So instead of just multiplying by the square root of 2, what we needed to do was multiply by 5 plus root 2. So let's start our examples now, and we'll retry that question, but instead of the method we used, we will try multiplying by the conjugate. Now, the 3 examples that we're going to look at here, for all of them, we are attempting to rationalize the denominator. Alrighty, so example 1. No surprise, 5 over 5 minus root 2. Let's multiply it by the conjugate, 5 plus root 2. And whatever we do to the bottom, we do to the top. Alrighty, what do we get? Well, on the numerator, we have 5 times 5, which is 25. And we have 5 times root 2, which is 5 root 2. And on the bottom, we can use the difference of two squares rule that we see up here. Okay, so let's highlight that. We're going to use this. So instead of doing a FOIL, we're just going to jump straight into this rule. We're going to do 5 squared minus root 2 squared. Now, there's nothing we can do on the top. We're just going to leave that as it is. But on the bottom, we get 5 squared is 25, and root 2 times itself is just 2. And we can see that we now get a rational denominator, not a surd in sight. And there is our final answer. 25 plus 5 root 2 all over 23. Okay, let's have a go at a second example. One on the square root of 3 plus the square root of 2. So this is another binomial denominator. So if we want to rationalize it, we need to multiply by the conjugate. That is the square root of 3 minus the square root of 2. And whatever we do to the bottom, we do to the top. Okay, now the numerator is pretty easy here. We've just got 1 times this square root of 3 minus the square root of 2. So no dramas there. And on the bottom, we get to use the difference of two squares rule again. Square root of 3 squared minus the square root of 2 squared. And what is the square root of 3 squared? Well, it's just 3. And the square root of 2 squared is just 2. We can tidy up the bottom. 3 minus 2 is 1. Now I'm going to put this step in, but we know that any fraction over 1 is just the numerator. So our final answer in example 2 is just the square root of 3 minus the square root of 2. Alright, final example for this lesson and for our Surds topic. 2 root 3 plus 5. Oh, let's write a proper 5, Mr. Laurie. Alright, all over 2 root 3 minus 5. What is the conjugate of the denominator? Well, it is 2 root 3 plus 5. And that's actually the same as our denominator here. But that's okay. That means we get to use our perfect square rule in this question, as well as our difference of two squares. Okay, so on the top we've got the same thing multiplied by itself, 2 root 3 plus 5 all squared. And on the bottom we can use our difference of two squares rule. We have 2 root 3 all squared minus, in the example it's actually the square root of 5. Square root of 5. Alright, so let's just go and fix that up. My bad. Square root of 5. Okay. So where were we? Sorry. Okay, so this 2 root 3 all squared minus root 5 all squared. Okay, that's better. Perfect square rule. Let's try and remember that. Okay, we've got the first thing squared and the second thing squared, and two lots of them in the middle. So 2 root 3 squared plus 2 lots of 2 root 3, well, times 5, plus the square root of 5 squared. So that's using our perfect square rule. Okay. And on the bottom, okay, let's focus on 2 root 3 all squared. 2 squared is 4, and the square root of 3 squared is 3, and 4 times 3 is 12. Minus the square root of 5 squared, well, that's just 5. Alright, back to our numerator. We just worked out what 2 root 3 all squared is, that's 12, plus, when we do 2 times 2, once again, I've forgotten the square root. We do 2 times 2, that's 4, and when we're multiplying surds, okay, so when we now multiply this and this, okay, we can just put them together under one square root, and 3 5s are 15. And at the end here we've got 5. And 12 take away 5, well, that is 7. And just tidying up, okay, by collecting the numbers, the rational numbers on the top, 12 plus 5 is 17. Okay, so 17 plus 4 root 15 all over 7. There is our final answer. Alright, so let's recap. Today we looked at rationalising the denominator, but for questions involving binomial denominators. And we found that we couldn't use the same method as what we did for monomial denominators. We had to go and utilise the difference of two squares rule, because the product of a binomial surd and its conjugate is always rational. And then we looked at 3 examples where this was the case. Well, thank you very much for listening. This, like I said at the start, this is our final digital lesson on the surds topic. So now, practicing this and doing the chapter review, I guess, to pick up on any spots that you feel you still need more practice with. Alrighty, bye.